So we are on this block of cheese, not this block of cheese or slice of cheese is this one. So I have not prepared, but this will be great. That's what makes it fun. Is when we just don't know what to do, or rather, the first one's a you do. No, I know I'm just so mean. So we got this plane right here is actually I think it's this thing right here. So it's like it keeps going, of course. But that slice, I'm pretty sure, is the plane. And note that it doesn't have a z. So what does z equal? It could be zero. It could also be anything, infinite. So if you notice, doesn't that plane go all the way up and technically all the way down? It's just that we're only looking at the first octant. So good times there. So that's what I'm thinking that plane is. The rest of it is going to be this cylinder. That's what they're calling it. Okay, cool, cool. Now I want to set up my limits for the volume. That last one just did not look good enough. You know what? Hold on. I want more room because you know how I'm going to write big and then tiny, tiny, tiny. So I'm going to use all the space that I can up here first. Now, did you want to do dz, dy, dx, dx, dy, dz? What do you want? Yeah, it's a good start. It's a good start to see what we can do there. All right, so then here we're looking at z equals and bleh, and z equals. So we're looking for a z equals something or other. What do you think? Like, looking at this plane, I don't think we can help that. But this has a z. Could it get z by itself somehow here? What would you do? And so then 9 minus y squared. Now this is technically plus or minus because of the square root of both sides. But it seems like we're looking at the first octant. Therefore, at the bottom we have, yes, and then this square rooty thing. So then we're looking at y's. Now, what I would like to do, and this is just a strategy, is to redraw it in, not like that, in 2D land. Because z doesn't matter anymore. So I'm only looking at x and y. Basically, you could see, I'm going to use the different color here. I'm looking at this triangle down here. That triangle is this triangle. Notice the x is bigger. So I made a bigger x, So I want to have this region now. How can I define top and bottom for y? What would be on the bottom? What's this line? 0. Okay, so how do I get this line right here on the top? How do I make a line there? Yeah, actually, that makes a lot of sense. It's very simple. It's in terms of x. I could see that. Yeah, I could see that making sense there too. Okay, cool, cool. Yeah, so I like that. Let's try that. Hopefully that works. And then finally for x, I'm wanting to know from here to here, right? So 0, obviously, until how far out would it go? Yep, if this equals 0 and you solve for x, you would get x equals 3. So this probably is a 3. And we're ending on a number, which is good, so we can get an actual number value in the end. So now I get to write tiny, 0, 0, 0, 3, 3 minus x, and then all that stuff. That square root stuff. 1 dz, dy, dx. All right. I think the first integral is super awesome. What do I put on the inside here? Perfect. Perfect. Makes it easy, right? We like easy. Easy good. And then not so easy. Am I right? I need to now integrate that thing. You look tired. Okay. Okay. How do I integrate that square root? Because it ain't u sub. Oh my gosh! Did you just say trig sub? Did you? And you're not banished from the class yet? Oh, for reals? You already know the answer then. So, yeah, the arc sign, you got it. I'm going to just follow a formula. Just going to follow the formula. Much easier. So, for this guy, this is an A is equal to 3. And then I'm just basically doing my formula. So here we go. I got the 1/2 in the front. I got y square root of 9 minus y squared plus 9, the arc sign, can't spell, arc sign of y over 3. Close, close, from 0 to 3 minus x dx. Oof. Well, that was just so beautiful. Good suggestion. Crisis averted. Yeah. But not really, by the way. It just doesn't look any good. It's like, wow, you just put me in a very bad spot here. I know, I'm sorry. Yeah, so let's do this. Let's pop in my x's. And then 0 doesn't cancel everything, but it will help. Oh, let me put the 1/2 in the front. That'll help a little bit too. Chad, I don't trust you anymore. Why is this the first question of the week? Yeah, this one's terrible, isn't it? And then I'm going to minus, and so whenever I plug in 0, here I'll get a 0 because of the thing in the front, and this arc sign of 0 is definitely a 0. Like, I have no issue with that. So basically the 0, I'll just erase that entirely. We don't need any of that. So that's good. That's at least something. I feel like I can simplify this before we keep going. Like here, if I have my little square and I got a 9 out of it, my 9s will cancel. I just don't know if that's worth it, because I'm looking here, we could do a u sub almost directly now, just as it is. I feel like that. Yes. And then this guy right here, if I, divide them both by the 3, again, I don't know. What's my integral of arc sign? Pain. Hey, good thing I have a formula for that somewhere. At some point, it's just annoying now. That's not too bad. I think we can do this. We got this, okay? We got this. No discouragement. We got this. Okay, so u is going to be 3 minus x. Du is negative dx. So dx is negative du for that little side over there. So then what I actually have is u square root of 9 minus u squared du. And this is going to be a negative in the front now. Okay. And it's only for that. This guy right here, I think we're just going to have it as it is. So 9 arc sine of this stuff. And just dx, I guess, for that guy. It will be now. Yeah, I'm not. Yeah, I mean, it is a U sub technically, but so I did a U here. Now that I can do a V substitution. Oh my gosh, Chad, I hate you. The reason why I had to do that is because obviously it's looking like I'm getting close, but it's not. I can't just integrate that. I have to actually do some math for it. Yeah. Okay. Right, tinier. I'm having the same problem. So there's a negative here, and there's already a negative there. So it's actually going to end up being a positive. 1/2 in the front, square root of v dv. And I don't know about the arc sine yet. I'm just going to try a big formula for this guy. So plus, and then 1/2 times, and then I'm just going to do the arc sine thing. So I have to do it with u, and u is going to be a -1/3. So I want to say it's u is equal to -1/3 x, kind of. Just, I don't know. No, that's... No, I don't like it. Okay, hold on. U, V, W. Okay, y'all aren't throwing something yet. Just because you're still writing. Exactly. Yes. After you're done taking notes, I will throw many. Yeah, that's weird. I know. I'm just trying to be able to get some integration at all. So here we go for this side now. It's actually going to be a 9/2 because the 9 right there. Arc sine goes to, here we are. We got W times, arc sine of W. Oh no. And then we got another one of these square root dudes. I know how much you love those. And then I'm going to multiply this whole thing by -1/3, I think. No, it's times -3. At this point, you're just unhappy. I know. Me too, man. Me too. Okay, so we took that integral. This integral is at least easier. This is 1/2. I add 1 to the power, divide by the new power, so that would be a 2/3 v to the 3/2, and then blah. The 3 will combine with this guy. I really hope this will work. Every single step, it's looking worse and worse, like it won't work. And the water keeps getting bigger and higher, and you say, no, I just got to get past this little bridge. It'll be fine. And it just gets worse, and it gets worse. Whew. Let's plug it in and see what happens. So my W's are actually these X's. V's are actually U's, are actually X's. Oh my goodness. So this thing, it needs to go here. Desmos. So wow. This is okay. 9 minus 3 minus x squared. And then this is all to the 3/2. All of this is going to cancel. Just watch. It's going to be like 2. 27 over 2. This here is 3 minus x all over 3. Arc sine of 3 minus x all over 3. plus the square root of 3 minus x all over 3 squared. From 0 to 3. Desmos. Yep, I'm going to do it. Here we go. I'm going to go bloop. And yes, oh, I know. You hold on. Okay. And we're going to minus. And then you can see almost everything. I think that's good. Is that good right there? Okay. Scientific. Now I'm going to type blind. Squared 3/2 2 3 minus x all over 3 all squared. Yeah, and then I'm going to say x equals 0 and x equals 3. I'm getting real numbers. I don't know. So plugging in a 3, we got -9. I'm just going to write down. I have to write somewhere. I'm going to write right here, I guess. So we got -9 minus, and I'm going to plug in a 0. I wonder if degree radian mode means something. Ah! Oh, we still got -9 for that guy. 21.2057. Let me put those together. So 21.2057 minus 9. And then I want to see what their answer is. I'm going to flash the answer. Okay, now hold on. Did we get... Oh, there's the -9. Oh! Boom! Math time! Okay, so yeah, but we need to still get that pi out of there. We are so close. Let me just try 1 divided by pi in the front. Oh yeah, I need to do parentheses around the whole thing. That's right. 1 over pi. Oh! Solid. We got it. Okay. So, now that I know that it works, are there any questions? I want to recap a little bit, okay? Can I go back through the whole thing? Just slowly? You okay with that? Make it easier? Yeah. So dz, dx, dy. Yeah. Sure. Yeah. I mean, yeah, there's a lot of ways to do it. I'm not going to. Now that I got it, I'm not going to. So, anyways, so real quick recap on what we were doing here. Yeah, we started with that square root, and it wasn't that friendly, but we did have a formula, which is okay. And then I had to toss in this thing, which made it just more annoying. But then I had formulas for those eventually. Here, let me scroll a little bit. Now you can get a bigger picture. So this square root right here, we did like a u substitution essentially, which made it pretty easy. Okay, that's that one. The arc sign had a formula, but I had to kind of get it in the right shape, which we did. And then I just plugged in x all over the place because it was easy to go 0 to 3. Now, how would I have gone like from this to exact answer, right? That's the harder part. Well, I did plug it in, and when I plugged in a 3, I got a nice easy number, which is really cool. So that kind of helps a little bit, right? So the goal here is actually just what's going on when I plug in a 0. What's going on? And 0 should be pretty easy to plug in mostly, okay? So let's plug a 0 in right there. I'm going to use a different color. I'm going to use a different color. All right, so right here, right here, right there, right there. So if I plug a 0 in, I got 9 minus 9, which makes that whole thing 0. So we're good there. When I have a 0 here, I got 3 over 3. And I got arc sine of 3 over 3 is 1. So what is the arc sine of 1? Yay! Very good. And you can verify by doing degrees. Right? Good. Yeah, pi over 2. You're right. So that's pi over 2. And then times 1. Right? Because 3 over 3 is 1. And then right here, again, plugging in a 0, I get 1 squared minus 1. So this goes away. This goes away. This is pi over 2, all that stuff. And then we have this guy in the front. Is that the final answer? 27 over 2? Oh, right here, look. And the 2's combined to make a 4. There it is. So not too bad in the end. But yeah, that's pretty crazy. Good thing we did that together. I'm glad it wasn't a you do. No, it's not. It's a terrible exam question. So when I'm going through the exam questions soon, I'm planning on doing them so that I know that, oh, I could do that. Yeah, I think I did that on the first exam.
Yes, because we had a problem that was on there that you realized that we needed a graphing calculator to solve.
Yeah. Okay. Well, now that we have that out the way, it says find the average value of this blah, 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 average value. Okay, now hold on. The average value in the first octant, I think they're just saying like the average value of like the height, I guess? I don't know. It's like a volume is what I'm thinking. Anyways, average. Pretty simple. We're going to say triple integral of f dv. Triple integral dv. Right? That's my formula. It says first octant by these planes. What is this shape? First octant by these planes. It's a cube. And oh my goodness, that's so nice. So much better than the last one. What are my limits on the bottom? What's my limits on the top? Perfect. Perfect. So much better, right? Of x squared plus 2 dz dy dx. And then all over, well, it's a cube. It's a cube. 4 times 4 times 4. There you go. Oh.
Since we know that basically x, y, and z are all the same, that's how we know that it's just 4 times 4 times 4.
Yes. Okay. Yep. You got it. Cool. So integrating in terms of z, there are no z's. You add a z, you toss in a 4, you get a 4 in the front. Integrating in terms of y, there are no y's. Wait. Is this 64? That'll just make it easier. There's no y's. You toss a y in the front. Goes from 0 to 4. Now we got a 16 in the front. This one we actually have to integrate. Wow. What's the integral of x squared? Perfect. And then we got a 2. Perfect. From 0 to 4. Plugging in the 4, we get numbers. 4 cubed is 64. I'm pretty sure. Still. Then all that over 64. The 0 cancels everything. Numbers! Wow, was that just so much better? That needed to be the you do. Flash the answer. We got it. That was an easy one. Oh yeah. Please, I can wait. You know what? I'm gonna get some coffee. Yeah.
That's just basically because we're plugging in, like we add a Z onto the front, turn that to a 4, then the 0 would cancel out, and then just keep doing that step, right? Yeah. Okay. That's exactly what it is. 4 to 16. Yeah. Yes. I just wanted to make sure I was on the right path. Exactly right. Very good. I need to bring a coffee mug. Easily start.
Yeah, you need a cool math professor title. Some sort.
Yes. I cubed over 3. No, because I'm such a terrible handwriter person. Sorry. So it is official. I'm addicted to caffeine again. I get headaches often over the weekends if I don't have something. So I've been drinking tea, so much tea at the house. I just down it. There's another one down it. Oh my gosh. Hmm? Yeah, I know. It's okay. Well, it's technically an addiction. Okay, it's technically. Just this society thinks this is acceptable, but other things are not. Good, good. Oop. All right. Sweet. I love easy problems. Oh, at least they just tell you. Oh, change the order of Okay. Yeah, this is okay. Perfect. Let's just talk about this one. Let's kind of just chill out with this. It'll be great. I want to look ahead right quick though, okay? Because we need to have all the chapter 15 stuff done before the exam. The exam is not right now. It's like in a week or two, 2 weeks. I don't know. I'm hoping it's in like 2 weeks. Anyway, so we got all this junk coming up. And I say junk because I really don't like that section. This one's really fun. Let me just look ahead. I'm just looking ahead. And then this guy, I think, is the last one, Jacobians. Jacobians are pretty cool. I don't think there's very many questions about it because I didn't like what my math lab had to offer. But I had to show Jacobians because they are pretty cool. So, like, yeah, that's a very short section. Okay, so we got basically this one question and 3 other sections, one of which is terrible, one of which is fun, and the other one which is short. So there's your analysis for that. And now we get to do this one. Okay, so let's just sit down, have a nice time with this one. We're not going to say this is the last question, hopefully, but you know, Cal 3, you never know. They say that going down this road right now would be bad. Oh, so why? Why would it be bad? Well, why's right there? No, like WHY. Square roots are on the bottom. That's not very fun.
Not to mention it's cosine x squared in the parentheses.
Okay. So the very first thing we're supposed to do, I don't even know if I have a formula for, right? That's disheartening.